All right, everybody, it is 10 o'clock. Let's get started. Good morning and welcome back to our coffee break series. My name is Jeff McBride and I, along with Andrew Schmidt, work in our VRV department. Both of us are sales engineers here. We also have Sharon Sims as our VRV inside sales and project manager. Jim Charlton is our VRV construction manager, and we'll find that Jim spends most of his time in the field helping contractors manage projects and providing Daikin VRV best practice knowledge. We have Brad Wilmes, who's our VRV technical advisor and startup and commissioning expert. And we also get tremendous support from Tony Faxon, who works directly for Daikin, and he lives here locally as well. Today, I'm excited to introduce to you all a product for VRV condensing units called single point power with phase monitoring protection, or SPPP for short. It's a little bit of a rough acronym for me to pronounce consistently, so today you may hear me refer it to as SPP or SPPPP. Getting the 3 Ps after the S is for some reason difficult for me, and maybe it's not for you, but maybe try it after and see if it's difficult. We're thinking maybe we're gonna have to rebrand it if I can't pronounce it. Another acronym I'd like to get clear on is the term VRV. Sometimes it causes confusion in the VRF world. VRV stands for variable refrigerant volume, and Daikin trademarked VRV in 1981 when they invented the product. VRF stands for variable refrigerant flow and is the term used by other manufacturers for their similar technology. These two terms are synonymous. Today, I'm going to cover a few subjects related to SPPP, the building electrification movement in Denver. We're going to go over some general terms of a brownout versus a blackout and how each can impact VRV systems. What is SPPP and why is it important to VRV systems? And quite important to this subject that I'm sure you all want to know is, will SPPP add cost to my VRV projects? And lastly, we'll touch on some of the long deliverables related to SPPP when specifying, which will be important. Before I get into those subjects, though, I thought I'd add a little background as to why we are encouraging the use of SPPP going forward. As some of you may know, Daikin entered the US market with VRV technology back in 2006. They've since built a 4.1 million square foot manufacturing facility outside of Houston, Texas, where they are manufacturing the entire North American market's VRV condensing units. Long has been the Daikin representative in Colorado and Wyoming since that Daikin came into the United States. We now have over 1,000 VRV projects in Colorado and Wyoming. We've had a number of installation-related issues over the years, but in some very rare cases, we found electrical issues not related to installation. To my knowledge, we've had 3 bugaboo projects that have had significant electrical problems, which have caused considerable damage to the electronics inside the VRV condensing units. Talking with other Daikin manufacturer reps in other states and also competing VRF reps here in our own state, they too have had some befuddling projects with electrical related problems. The situation that unfolds in these rare cases is painful for all parties. The owner, the architect, the engineer, the GC, the mechanical and electrical contractors, the rep, and the manufacturer all feel pain. Power issues are extremely hard to prove, and we live in a prove-it environment when equipment fails. It is almost impossible to prove an electrical event or electrical anomaly without some sort of electrical monitoring device or devices. Unfortunately, without that prove-it device or monitoring system, none of the ownership groups or representatives at these sites have been simply satisfied that their newly purchased equipment was harmed electrically. Prove it, they tell us. They want a smoking gun related to the when, the why, the how, and basically show us that your equipment isn't defective and at fault. Again, this is not unique to Daikin, and it has occurred in the United States with other Daikin reps and also other VRF manufacturers. In our 3 cases, we've been able to prove the components at these sites failed electrically. We have cut open failed compressors and found that the windings in them were severely burned. We have tested failed electrical boards and found circuitry burned. We've had third-party testing and sent some of our samples to Daikin for testing. In all the cases, the conclusion was that something electrically burned these components to failure. So we asked ourselves, even though rare, How can we solve this painful issue and not add cost to our projects? Back in January of this year, Andrew and I went to AHRI in Las Vegas, and at the Daikin display booth, we bumped into another Daikin rep covering a different territory on the West Coast. We struck up a conversation, and lo and behold, this rep too has had some similar electrical but rare issues in their market. And they had enough pain in their market to work on the problem themselves, and so they invented SPPP. Oops, sorry about that. Building electrification. I would assume that most everyone attending today is aware that the city of Denver approved an ordinance last fall that has electrification of commercial and multifamily buildings as a major component of the ordinance. I'm not here to debate the merits of the ordinance. I'm sure everyone has an opinion about it. We have many differing opinions just here at Long. I'm just stating a fact that electrification is here at our doorsteps right now. In many ways, VRV or VRF heat pump technology is a major beneficiary of this movement, as these systems only operate and use electricity. We've all heard terms related to electricity such as dirty power, brownout, blackout. In the news, I read almost daily about the western half of the United States' current drought conditions and how this drought is affecting our reservoirs at Lake Mead, Lake Powell, and other large water storage bodies. The focus I've seen lately is how drought may soon impact further hydroelectric capacity within the Colorado River Basin, which is a resource that much of the western United States relies on for electricity. I read an article just last week titled, "How the Western Drought is Pushing the Power Grid to the Brink." I see similar articles in the news almost daily. Just this morning, I got a news notification that was titled, "Huge Dinosaur Tracks Appear After Drought." Interesting, I haven't read it, but it'd be interesting to read that one. But this is current news, and I personally wonder what will happen to our grid as more electrical devices are connected to it. All right, so what's a brownout? Brownout is caused by higher electricity demand versus utility capacity. A blackout is a large-scale service interruption where the power is out completely to certain areas, often caused by severe weather or utility equipment failure. Both can negatively affect VRV electronics. Brownouts can cause dirty power or fluctuation in flow of voltage. Blackouts can be suddenly off and suddenly on, causing a surge in voltage when the blackout is over. Drought and more electric devices connected to the grid seem to indicate to me that we may have in our future some of these brownout or blackout conditions right here in Colorado. I certainly hope not, but I'm not sold that we won't. As I just mentioned, brownout conditions can be damaging to VRV systems because the utility doesn't have enough capacity to meet demand, so will modify the voltage to certain areas in their district. This is where the term dirty power comes from and can be detrimental to electronic devices. Commercial three-phase VRV systems in the US come in two voltage ranges, 208, 230 three-phase, and 460 volt, also three-phase. There's a 10% tolerance to voltage, and you can see the chart range on this slide. The biggie here, though, is that once voltage is established, all three legs have to have a 2% tolerance to voltage from one another. VRV condensing units thus require consistent voltage, or in other words, clean power. Lightning strikes, brownout, blackout, all can cause phase imbalance or voltage intolerance well outside 2%. VRV systems have many electrical components. There's a main E panel that has various electronic boards that control different aspects or functionality of these systems. One of the main boards is called the inverter compressor board and modulates the capacity steps in the compressor. These steps are one of the reasons VRV systems, which are heat pumps, are so efficient at using electricity. I personally like to think of VRV systems as computers that use the refrigerant cycle to move BTUs around various structures or buildings. The 10% range in voltage in either electrical category is not an issue. It is the fact that these systems require 2% tolerance on any three leg of power once the voltage range has been established at the site. It is common practice to use power surge devices for our computers. And in fact, as I look at my desktop setup for this presentation today, I find that everything is plugged into my surge protection device, and I imagine yours are as well. SPPP stands for single point power with phase monitoring. The phase monitoring component will protect the electronics from dirty power, which is a phase imbalance or loss of phase discussed previously in brownout or blackout conditions or even lightning strikes. The phase monitor has a data logger that will record power events. So it has that prove it mechanism the owners require, but more importantly, it can be set up for the 2% voltage tolerance the equipment has. If it senses a voltage disruption, the phase monitor will stop power from going to each condensing unit. Once voltage is reestablished at 2%, the phase monitor can be programmed to reset and restart the system without manual reset. So you don't have facility management folks running up to the roof to do a hard reset to get their system or systems running again. Along with the phase monitoring device, single point power is another main feature of this product. VRV condensing units range in module numbers: single module, double module, or triple module condensing units. So you have 1, 2, or 3 condensing units with a 60 to 40 ton nominal range. Traditionally, each condensing unit requires its own electric circuit. With SPPP, double and triple modules have one larger circuit from main panel instead of 2 or 3. So when using an SPPP, it will shrink electrical contractor scope, as they won't provide any junction boxes or disconnects, and will also have to provide less circuits, less conduit, less wire, which in addition will save them labor by not having to install any of this extra equipment. Here's a picture of an SPPP used on a double module VRV twin condensing unit system. You can see the SPPP box on the far left of the left condensing unit. These two condensing units share a refrigerant network. One circuit runs from the main panel to the bottom of the SPP box, and then wire whips, 2 of them, run to each condensing unit to provide the power they need. The electrician simply mounts SPPP near the condensing units, wires one larger circuit from the main panel, and from SPPP, they run short wire whips to each condensing unit. Some of the benefits to using SPPP on your VRV projects: phase monitoring, single point power for double and triple module condensing units, less equipment for electrical contractor to purchase and install, and simplification of who does what within the trades. I add this last bit because there have been many instances where phase monitoring and or disconnects are added in the notes of the VRV condensing unit schedule, which on the surface is great. However, neither are factory options, and so we've seen instances where the mechanical contractor or electrical contractor are confused as to who is providing these required devices, even though they're in the long exclusions as non-factory options. Of course, a really big question I'm sure all of you have is, will SPPP cost more money for my projects? The answer is no. EC scope and material and labor will shrink accordingly, as mentioned a few moments ago. The use of SPPP on VRV projects is thus a win-win-win. The owner benefits with a savings related to reduced electrical scope, and yet gains phase monitoring protection for the life of their investment. The rest of us win by not having to investigate and find that prove it moment or event because the phase monitor has it. Long deliverables related to SPPP will provide new condensing unit cut sheets showing updated MCA MOP values when scheduling SPPP. We'll provide updated WebExpress electrical characteristics in the selections we send you. When condensing unit sizes are finalized through the design iterations, we will also update the electrical wiring diagrams in our WebExpress program to reflect the use of SPPP. And finally, our field construction and management team will meet up with mechanical and electrical contractors to ensure scopes are straight. Here's some example language to use when specifying SPPP. I'm not going to bore you with reading this word for word. Just want to let you know we've developed some language that may be helpful when specifying it. We're also working to update our VRV guide spec and hope to have that out later this fall that will include SPPP. All right, that is it for me today, folks. Enough SPPP. Hope you found that informative. Last but not least, here are VRV team contacts. If you are interested in learning more about SPPP or have specific questions, please reach out to us. Andrew and I both look forward to working with you all on your next VRV projects and continuing our quest to bring you and your customers products like SPPP that enhance and protect their VRV investments long-term. Please join us next week, Thursday, September 1st. Our own Jeff Rodell will be hosting Don Cameron, who's with Yaskawa. Don will be covering Denver Fire VFDs, Halo multi-purpose IoT sensor, security, safety, and health. That's a mouthful. Thanks, everybody, and enjoy the rest of your Thursday.